All right, 7.0, angles of parallel lines cut by a transversal. This is kind of like some prerequisite stuff that we're going to need for Chapter 7 and pretty much all the second semester when we get into some geometry stuff. So objectives, students will be able to identify specific angle relationships created by a transversal. Transversal is just a line that cuts through two other lines. So transversal parallel lines, these specifically are parallel. So something really unique happens when you have two lines that are parallel, which means they have like the exact same slope. And which relationships are congruent and which are supplementary. So we're going to talk about that. So here we have line M and N. See, M and N, these are parallel lines, and line L is the transversal to those lines. That's all that means. Transversal is just a line that cuts through two other lines, at least two other lines. When you have a transversal of parallel lines, like we have here, right? Transversal of two lines that are parallel, you get a special relationship of angles as listed below. So here's some of the listings, except for there is a typo here. So you're going to want to go ahead and just fix this. This shouldn't have said consecutive because this is consecutive down here. This should have said corresponding. So I apologize for that typo. Okay, so here's all the different relationships you get. So corresponding angles basically just means they're in the same corner. So you can see 1 and 5, they're in the top left. So that's an example pair of corresponding angles, is 1 and 5, they're in the same corner. So like another example pair would be like 2 and 6, they're both in the top right corner. So we're going to just say angle 2 and angle 6. That's another example. All right, so the next one here is alternate interior, and it sounds exactly what it means. The alternate just means that it's on different sides of this transversal, and the interior means that it's on the inside of these two parallel lines. So alternate interior would be like 3 and 6 as an example, and another example is 4 and 5. So we'll say angle 4 and angle 5. Okay, the next one is same side interior angles, and this is the one that's also called consecutive. So that's why I wrote consecutive here. That was a mistake. But this one is also called consecutive. But I like the same side interior because it just makes sense. Same side interior. Remember, interior just means inside the two parallel lines, right? Just inside here. Well, same side just means they're on the same side. So 3 and 5, that's an example of same side. And 4 and 6 is another example of same side interior. Okay, alternate exterior, exactly what it sounds like. Exterior meaning that we're on the outside now. Outside, exterior of the two parallel lines. And alternate meaning that we're going to be on opposite sides of the transversal. So that's why 1 and 8, that's alternate exterior, and also 2 and 7 is an example of alternate exterior. Okay, lastly is vertical, and vertical is one that we're going to see the most. And I would definitely encourage you to memorize vertical angles. This one is what you're going to see often. Just we see it all the time. We see alternate interior quite a bit as well. Alternate interior shows up a lot, but vertical shows up the most. And vertical is simply this. It is just angles that are across from each other. So when you have two lines that intersect, it's the angles across from each other. So 1 and 4 is a good example. 2 and 3, 5 and 8, 6 and 7. Those are all vertical angles. So let's just say, how about 5 and 8? Those are vertical angles. This is another example. Okay, now, all of these angle relationships are either going to be congruent. So congruent, which the symbol that we use for that is like an equal sign with a squiggly line above it. That means congruent, which means they're the same. That means they're exactly the same. So if you see two angles that are congruent, that means they have the exact same size. Or they're going to be supplementary. So all of these angles are either congruent or supplementary. And supplementary means they add up to 180 degrees. So they're either going to be the exact same or they at least add up to 180. That means like maybe one's 100, the other's 80, or maybe one's 40, the other one's 140. That's always going to be the relationship, either congruent or supplementary. Now, there's another kind of angle that you're not going to see in this dynamic, but another vocab word that you might use is called complementary. And that means that the angles add up to 90 degrees. And here's kind of how I remember this. If you think about 180 degrees is a straight line. That measure right there is 180 degrees. So I think of supplementary starts with S, and they make straight lines. Well, 90 degrees, if you think about 90 degrees, is always a little right angle like this, right? That's 90 degrees. So I like to think that complementary angles make perfect corners. Complementary angles make corners. Supplementary angles make straight lines. Just an easy way to remember those two vocab words. Okay, what I want to show you is, here's just a basic diagram of, here you have two parallel lines cut by a transversal, and then those transversals are also parallel lines, and so that makes these transversals. So you just have two parallel lines cut by two parallel lines. So you get a bunch of these angle relationships. And something you can do to just quickly tell whether or not they're congruent or supplementary is get out your highlighter and just highlight every other. So you can highlight every other, like highlight the ones across from them as well. So like I just did, that'd be 3 and 8, and then 11 and 16. And then you could get out a different color and you could highlight every other there as well. And basically, if they're the same color, they're congruent. And if they're different colors, they're supplementary. So yeah, like if it's all the same color, it's congruent. And if it's two different colors, it's supplementary. Simple as that. So that should help you kind of identify the relationships here. So like what we're saying is 1 and 6 have to have the exact same measure. And so 1 and 6 would have to have the same as 9 and 14 and 3 and 8 and 11 and 16. So because they're all congruent. Same thing with 2 and 5, they got to be the same as each other, and they got to be the same as 10, 13, 7, 4, 15, and 12. They all have to be the same because they're congruent. But supplementary, so that means like 1 and 5, they add up to 180. Well, they make a straight line. But the same thing's true with like 1 and 15. If you were to take angle 15 and slide it over here, it would perfectly match up with 1 and make a straight line. So any two with different colors would be supplementary, like 4 and 14, they're going to be supplementary, or 16 and 13, they're going to be supplementary, or 12 and 6 are going to be supplementary. So just kind of that's an easy way to do it, and that's kind of what I described over here. Okay, let's move down here. So it says, using the diagram above, name the relationship of the pair of angles given and tell whether they are congruent or supplementary. I'm going to do one with you and then I'll let you guys do the rest on your own. So let's look at 9 and 11. 9 and 11. Well, 9 and 11 have the same color, so we know that they're congruent. Also, the name of the relationship, look, they're in the same corner, so they're corresponding. So we're going to say that they are corresponding angles and they are congruent. I'm just going to use the congruent symbol because it's a lot easier than spelling out congruent. So they're corresponding because they're in the same corner, and they're congruent because they have the exact same measure. All right, so take a minute here and try and do 2, 3, and 4 on your own. See if you can figure it out. The video is gonna pause, and then you can just unpause it when you're ready to check your work. Okay, hopefully you went through there and you saw this. So 4 and 15, let's start with those. Here's 4, here's 15. Well, notice that this is the line that they share, so that's the transversal, so these must be the parallel lines. And if you think about the parallel lines, they're both on the outside of the parallel lines, so they're exterior, and they're on alternate sides of this transversal, so they're alternate exterior angles. And if you notice, we already highlighted them. They have the exact same color, so they have to be congruent. Okay, 6 and 7. 6 and 7, look, they're different colors. Different colors, so we know that they're supplementary. And if you look, they're sharing this line. So this is the transversal, and these now are the two parallel lines. And they're on the inside of those two parallel lines, and they're on the same side of this transversal. So these are same side interior. And then vertical angles, 12 and 15. So here's 12, here's 15. Vertical angles are the ones that are across from each other, like these are. And they're already highlighted the same, so we know they're congruent. But vertical angles are always congruent. That's something that you just may want to make a note of. Vertical angles are always congruent. Okay, so that's just kind of an introduction to the angles. Let's go on to the next page. So now here's how we can use some of these relationships to solve some problems. And this is primarily what you're going to be doing with this. So here you can see that they want us to solve for x. Well, we could see that 5x represents this angle and 2x plus 24 represents this angle. Well, what's the relationship of these angles? Well, they're across from each other, aren't they? That means they're vertical. And we just said vertical angles are always congruent. They're always the same. In fact, these little angle marks that I put here, since they're the same markings, that means that they're congruent. I could also do this. I could also say that these angles here, I could do like a double line. And now these ones are also congruent. And that makes sense. They're vertical as well. Well, we don't know anything about these angles, but we do know something about these two. We know that these are congruent because they're vertical. So since they're congruent, we can set them equal, and that's how we're going to solve. So we're going to say, hey, 5x has to equal 2x plus 24. Well, now it's just a simple algebra problem, right? So now I'm just going to subtract 2x, and I get 3x equals 24. And then I'm going to divide both sides by 3. And I get that x equals 8. And what do you know? I solved for x. And I could take this and plug it back in and make sure they're the same. In fact, if I was to plug in 8, I would know that this is 40 degrees. And if I plugged in over here, 2 times 8 is 16. 16 plus 24. Hey, what do you know? That's 40 degrees. And that makes sense because we already said they should be exactly the same. Okay, so that's how you can use these relationships to solve for certain parts, solve for missing angles, solve for variables. Is you just got to think about, hey, how are these things related? Make a little equation and set it up from there. So like this next one, example 2 says solve for x. Okay, well, you'll notice that we don't know these two angle measures, but they do tell us that ABC, that's this whole angle here, is 145. Well, if you think about it, that means these two angles have to add up to 145 or have to add up to ABC. So kind of the way you would start this is you would say, hey, I know that angle ABD plus whatever that measure is, plus the angle measure, and usually you might see a little M out here for a measure of angle DBC. These two angles together, they have to equal the measure of angle ABC. And that should make sense. All we're saying is, hey, whatever this angle is plus whatever this angle is has to equal the whole angle. That's pretty basic. That's known as the angle addition postulate. It's really simple. These two add up to the whole thing. That's it. Well, if that's true, then we could put in some of these variables. We know that angle ABD is represented with 2x plus 10. And we know that angle DBC is represented with 4x minus 3. And they tell us over here that ABC has to equal 145. So I could say, okay, well, that has to equal 145. All right, well, now we just have a pretty simple algebra problem here. I'm going to combine like terms, right? So I have a 2x, a 4x, I have a 10 and a negative 3. So this should be pretty easy to go from here. 2x plus 4x is 6x. 10 and negative 3 is 7. And that equals 145. Now we're just going to go into our algebra, negative 7, negative 7. So I get 6x equals 145 minus 7 is 138. Divide by 6, divide by 6. I don't know that top of my head, so I used a calculator. 138 divided by 6 is 23. Boom. There you go. X equals 23. And if I wanted to, I could plug that 23 back in and figure out each of these angle measures, right? So like 2 times, I know the problem doesn't ask that, but some of them will. So 2 times 23, well, 2 times 23 is 46. 46 plus 10 is 56 degrees. This one is going to be 4 times 23 minus 3. Let's see, 4 times 23, that's going to be 80. 4 times 3 is 12, so that's 92 minus 3, which is 89 degrees. And something interesting happened here. This doesn't actually, it works mathematically, but there's something interesting about the way this problem is set up, and maybe you can recognize it, is that 89 is actually bigger than 56. But it doesn't look like it, right? Doesn't this angle look smaller than this angle? And so that brings us to a very important thing to remember, is that when you're dealing with geometry, especially geometry problems, looks don't matter. So just because this looks bigger, in fact, if you look at it, it actually kind of looks like a right angle, right? That's irrelevant. It doesn't matter. All that matters is what the math tells us, okay? Now, in real life, things should look like they are, right? So 56 degrees should look like 56 degrees. It shouldn't look like 90. But you're going to see a lot of problems here where, you know, something may look 90 degrees, and mathematically it's 56. So just trust the math. Don't trust the way it looks. Very, very important. You'll just see that a lot. Okay. Last problem here I want you to try, but I want you to just think about it. Let's get the highlighters out, right? If I was to highlight this angle, that would mean I would highlight this one the same. Then I'd highlight this one because remember, these are corresponding angles. They're in the same corner, so they're going to be the same. And then this one would be yellow. Okay, well, if you highlighted all the other ones, then this would be green, 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 green. That should tell you something about the relationship of these two angles. So think about that, think about what that means, and think about what kind of equation you can write, and then try and solve it. Okay, I'll let you try that all on your own. It's okay if you get it wrong, but give it a shot. And when you're ready, unpause the video. Okay, so what you should have seen is that since these are different colors, that means instead of being congruent like these ones are, they must be supplementary. They must add up to 180. So I went ahead and just wrote that equation. Hey, this angle plus this angle has to equal 180. From there, you're just going to combine your like terms and just do some algebra, and you end up with b equals 34. But let's real quick just plug in b equals 34 and just kind of evaluate this. Let's see if it's one of those situations where it looks right. So 2 times 34. Let's see, that would be 2 times 34 minus 15. Well, 2 times 30 is 60, 2 times 4 is 8, so this is really like 68 minus 15. And 68 minus 15 is 53. Okay, so this one actually looks right, because this looks like it's an acute angle, so it's got to be less than 90. So 53 degrees actually makes sense here. So let's check this one then. 3 times 34 plus 25. 3 times 30 is 90. 3 times 4 is 12. 90 plus 12 is 102. 102 plus 25 is 127. And that makes sense as well because this angle looks obtuse, and so 127 degrees would be an obtuse angle. And what do you know, 127 plus 53, I forgot to do the little degree symbol, would equal, that would perfectly add up to 180, just like we said it should be. So there you go. All right, all that's left for you is the summary. So I want you to list all the angle relationships and the ones that we listed on the previous page. And I want you to look at the picture and see if you can figure out, hey, which ones are congruent, list them over here. And which ones are supplementary, list them over here. I will give you a hint. Most of them are congruent, okay? Most of them are congruent. So, all right, give that a shot. Maybe do it right, maybe not. We'll talk about it in class. All right, see you guys when school starts back up.